I have a variety of power supplies in my workshop. Some are for 12 volts, others are for 24 volts, 5 volts. Many of them are from DVDs, woofers, and I also have laptop power supplies with a variety of different voltages at their output. But in this video specifically, I'm going to reverse engineer a power supply from a DVD. It is right here with a variety of voltages ranging from 5 to 12 volts. I chose this one because it is one of the few power supplies with not so much complicated parts. So here is the schematic of this power supply, but I'm going to explain for you step by step to understand fully how this switch mode power supply converted a 220 volts AC to a variety of DC voltages at its output. Take 1 second to like this video because it really helps out in the growth journey of this channel. From the schematic, the 220 volts starts from this left side. You can see it on the PCB. Taking a look at the lower side, it moves and connects directly to the fuse. Then as we continue with this trace, the fuse connects directly to the film capacitor and the choke. By the way, the function of the fuse is to trip the power when the circuit is drawing high currents. The fuse then connects to the film capacitor and the choke. The film capacitor prevents high voltage spikes from entering the circuit, and the choke prevents AC noise that may enter the circuit. If we follow the opposite trace, the wire connects directly to the switch. One of the white ports indicates where the AC enters and the other port indicates the switch. After the switch, it connects to the film capacitor and the choke. So far what we've talked about is the filtration stage. Next, the two wires from the choke connect directly to 4 diodes. These 4 diodes work together to rectify the AC to DC. A combination of 4 diodes is called a full bridge rectifier. After the diodes, we have an electrolytic capacitor to hold the DC charge. The negative part of the electrolytic capacitor connects to one terminal of the emitter of an NPN transistor. The transistor, I marked it as Q1. This transistor has markings on it labeled C945. Googling this part number gives you its data sheet. The positive part of the electrolytic capacitor connects to 2 resistors. One resistor connects to the base of the Q1 transistor. The positive terminal of the electrolytic capacitor also connects directly to the transformer, then proceeds to connect to the 100 kilo ohm resistor, 10 nanofarad capacitor and a diode, as you can see in the diagram. The other resistor that connects directly to the base of the Q1 proceeds and connects to the collector of the Q2. Along the same trace, there is also a 10 nanofarad capacitor and a diode, which are connected in parallel when the diode is in the reverse bias. Then from there we find 2 resistors that form a voltage divider. The base of the Q2 transistor is connected directly to the resistor, the diode and the capacitor. Then along the trace of the resistor we find another diode and an electrolytic capacitor which is called 10 microfarad. In between them there is another diode that connects towards them which is in a reverse bias, but it connects directly to the transformer. In front of it and behind this other diode that we have talked about, there are 2 wires that connects towards the opticoupler. It is called C748. While measuring some of the parts, for example measuring some points of the transformer, I used the multimeter in continuity mode to find out exactly where each leg ends. Continuing from the opticoupler, we find a TL494 adjustable shunt regulator. There are also resistors that are arranged in such a way that they provide feedback to the opticoupler with the help of the regulator IC. They do this by providing a reference voltage to the regulator IC by forming a voltage divider. There are also several capacitors and half-wave rectifier diodes to output variety of different voltages according to the capacitor ratings. There is also a 100 nanofarad capacitor that is connected to the regulator IC with relative to ground. The function of this capacitor is to help in the proper function of the regulator IC.